Algebraic expressions. Okay, this is the best way I have to do it. A bunch of variables and numbers together is an algebraic expression. Okay, that can be anything. I mean, an algebraic expression can be 0, it can be 2x, it can be x, it can be x over 2, it can be x squared over 2 plus 3x minus the square root of x. Whatever. That's an algebraic expression. We can even make this x squared y minus xy squared plus the square root of xy cubed. Whatever we want to do, these are algebraic expressions. Terms are products of variables and numbers. So things like this is a term. These are all terms because they're things multiplied together. We can understand this to be multiplied by 1. This we could write as 1/2 times x. So terms are things multiplied. No pluses or minus. So that's each one of these is a term. So this expression has 3 terms. 1, 2, 3. This expression, 1, 2, 3. So an important thing to know is the expression does not include an equal sign. This is not an equation, this is an expression. So you'll hear me say expression sometimes, you'll hear me say equation sometimes. Okay, the coefficient, this is an important word, is the numerical part of the term. Here, the coefficient is 2. Here, the coefficient is 1. Here, it's 1/2. Here, it's also 1/2. This one is 3. This one is -1. Oh, how is it -1? Oh, yes, because this is negative. And that's the easier way to do this. Okay, so let's move on to polynomials. So a polynomial looks like this form. So you'll notice that this a to the n, this is just some constant. And a to the n minus 1, another constant. And a1, a0. These are just numbers, And what we have here is we have powers of x. Just numbers with powers of x. And then added together. That's basically what we have. So this particular polynomial has a lead coefficient. Okay, lead coefficient is the coefficient of the term with the highest degree. And the degree, n, is the degree of the term with the highest degree. Degree meaning highest exponent. So what we end up with, so let's say I have 5x squared minus 6x plus 1. My lead coefficient equals 5, and my degree equals 2, the biggest exponent I see. Because you can also think about this. So in this case, my a sub n would be 5. A sub n minus 1 is -6, because I always think of this negative going with this one. And a0 is 1. So a couple of things polynomials do not have. There will be no negative powers of variables. There's allowed to be negative powers of the coefficients, but no negative powers of variables. So a polynomial could be 1/2 x squared minus 3. That's a polynomial. Not a polynomial is 2x to the -2 minus 3. Because this is actually 2 over x squared minus 3. Not a polynomial. Okay? So, no variables in the denominator, no radicals involving the variables. Another example of something that's not a polynomial is the square root of x. So 5 square root of x minus 3 root y. That's not a polynomial because we have variables under there. Now I can have the square root of 2 times x to the 5th minus the square root of 3 x to the 3rd. That's fine. Because these are just numbers. These are real numbers. The square root of 2 is a real number. 1.414 something something goes on forever. This is 1.72 something goes on forever. So this is okay. This one is a poly. This one is not a poly. So we have these monomials have one term. Okay. Binomials have two. So this is a binomial. It has two terms. Trinomials have three terms. So this first one we talked about was a trinomial. So this is all stuff you should have seen before in any algebra class that you've taken prior to this. So let's talk about combining like terms and removing parentheses. So like terms, when we use that word, those two words, having the same variable part. Okay. So just like if I said, what is 5 apples plus 3 apples? You would say, well, you have 8 apples. Yeah, that's what, we've been taught since we were 5 years old. Okay, same thing as I would say 5 x's plus 3 x's is just 8 x's. Okay, but what if I tried to say, wait a minute, 5 x's plus 3 y's? What's going on now? That's like saying 5 apples plus 3 oranges. If I tell you to go to the store and get 5 apples plus 3 oranges, yeah, you can't really take that out. Okay, I can't. 8 items, I suppose, but you have to say apples and oranges. I want 5 apples and 3 oranges is the simplest way to say what you want if someone goes to the store. Now, you can remove parentheses using distribution. So let's say that I have 7 times 5x plus 3y. So remember, what we can do is we can go 7 times 5x plus 3y. Well, that 7 has to act upon both of these guys. So that's 7 times 5x plus 7 times 3y. So that's actually 35x plus 21y. So these two things allow us to add and subtract polynomials. In fact, it allows us to do a lot more than that. So one of the things I want to make sure of, this is one of the problems that I see a lot in this class. So let's say that I have two polynomials that I want to do. Let's say I have 2x squared minus 3x plus 1 minus 2 times the quantity 5x squared plus 8x minus 3. That's what I want to do. Okay. Now, let's think about what we're doing here. Actually, you know what? Let's take the 2 out. I don't want to do that. Let's just say we're subtracting these two polynomials from each other. Now, one of the biggest mistakes that people make in this class and even in 221 and a lot of the classes that I've taught is they forget to distribute this negative all the way through. Or they write this without these parentheses right here. But if I want to take these two polynomials and subtract them from each other, my personal opinion is the best way is to write them vertically. And this is because we learned to do math this way. So here I would write negative 5x squared, then distribute this, negative 8x, negative 3 is a positive 3, because we take it back again. So now we can do this. 1 plus 3 is 4. Negative 3 minus 8 is negative 11. And 2 minus 5 is negative 3. And there, we're done. Okay, so you can either do it this way. This is my favorite way, because this allows me to line up the x squareds, and I know I have 2x squareds minus 5x squareds. and negative 3x's minus 8x's, and 1 plus 3. So when I line them up that way, it makes them make a lot more sense. And it's the same way that we would do any other thing that we were adding and subtracting. If I wanted 231 minus 583, for example, I'm still doing that. I'm going 1 minus 3. You're still doing the same thing. You're basically distributing these throughout everywhere. They're distributing through the 500, the 80, and the 3. So really not doing anything different in algebra that we did when we were just, you actually do numbers. You go 1 minus 3. Well, you can't do 1 minus 3. So you borrow a 10, right? That's how we do it when we're kids. And then let's see, 2 minus 8. And actually, we wouldn't even do it this way because then we're going to figure out that 583 is bigger, and we'd turn it around anyway. So we go 583 minus 231, 253, and then we'd make it negative because we know that's the negative one. Okay,